In this video, we're going to look at word problems in systems of equations. So at the top of this piece of paper, we have kind of some steps for us to follow on certain types of questions. There'll be some questions where they ask about how many items were sold or how many coins does this person have, and it'll give us some information. And our goal for systems of equations is to write two equations, and each of those two equations has two variables, and those are the same two variables, and our goal is to figure out what those two variables are equal to. So let's take a look at our first example and we'll work through that. First one says a jar of coins contains 40 coins. The coins are nickels and dimes. The total amount of money is $2.75. How many of each type of coin are there? Okay, so let's think about up here it says equation number one, x plus y equals our total number of items sold, total number of items, total number of coins. Okay, so they gave us that we had a total number or a total amount of 40 coins, and we know that there are nickels and there are dimes. We don't know how many there are. That's the goal of the question. So for right now, our first equation is just there are some nickels, there are some dimes, and we have 40 coins. So we can use x and y. Remember, if we use x and y, let the first variable they give us, or the first thing they want us to find, let that equal x. But for these word problems, you can use whatever variables you want. And a lot of times I like to use the first letter of the words that they want us to find. So here I'm going to use n for nickels and d for dimes. So I know I have n plus d equals 40. So that's like my first equation. Nickels plus dimes equals 40 total coins. Now I'm going to look at the amount of money and try and write my other equation. So what I also know about these nickels and dimes is that they add together the amounts and it equals $2.75. So here we have to infer a little bit about nickels and dimes. How much is a nickel worth? How much is a dime worth? And how is that going to give us $2.75? Okay, so we know a nickel is 5 cents. So we could write that as 0.05 cents. Times however many nickels we have is going to give us the total amount of money in nickels that we have. So we're going to add that to 0.10 times the number of dimes we have, because each dime is worth 10 cents. And we know that is going to equal $2.75. So now I have my two equations, and I can begin to solve for those variables. If I look at my second equation, I have decimals, and we know how to get rid of decimals. All we have to do is move the decimal to the right, the greatest number of decimal places. And here they all have 1, 2, 1, 2, 1, 2. Okay, so I would just move the decimal 2 times to the right, which is like multiplying by 100. And this equation becomes 5n plus 10d equals 275. And now we still have our other equation, n plus d equals 40. All right, and we know 3 methods to solve. We could graph these if we wanted to. We could use substitution, or we could use elimination. I'm going to go ahead and use substitution because it's going to be easy for me to solve this second equation for either n or d. So I'm going to take my second equation, I'm going to solve for d. Let's just solve for d. So if I solve for d in this equation, I'm going to subtract n from both sides, and I get d equals 40 minus n. So now I know that d is equal to this. And remember, substitution, I can take 40 minus n and plug it in right there for d. So I'm going to rewrite this top equation, and I'm going to say 5n plus 10 times 40 minus n equals 275. Now I can solve that equation to find how many nickels I have. 5n plus, distribute, 10 times 40 gives me 400 minus 10 times n, 10n equals 275. Combine like terms, 5n minus 10n is going to give me negative 5n plus 400 equals 275. Now we subtract 400 from both sides, and we write negative 5n equals, and that's going to give us a negative 125. Okay, so now we divide both sides by negative 5, and we get n equals, and we know we have a negative, well, we know based off a word problem, we're not going to have a negative number of nickels or dimes, right? Correct. Okay, so when we get to this point, we know we have a negative divided by a negative, and that's going to give us a positive, which is what we wanted to happen. And we do 125 negative 125 divided by negative 5, and we get 25. So I'm going to circle that and leave that for just a minute, because now we have to find how many dimes we have. Okay, so now we're going to take n equals 25, and I like to plug it back into one of my original equations. And I know this was technically one of my original equations, but this looks a little prettier, easier for me to work with after I multiplied everything by 100. So now this equation right here looks like it's going to be easy for me to find what d is equal to. So I'm going to take 25, I'm going to plug it right there in for n. So I'd say 25 plus d equals 40. Now I can subtract 25, and I get d equals 15. So now I know I had 15 dimes and I had 25 nickels. So I can leave my answers like that, or I can write 25 nickels, 15 dimes. And I can check my work. I know 25 plus 15 gives me 40. And I know that I could check the monetary value of 15 dimes and 25 nickels, and that should give me $2.75. All right, number 2. 900 tickets were sold for a performance. Orchestra tickets are $3 each, and balcony tickets are $2 each. The total money earned from tickets was $2,300. How many of each ticket were sold? Okay, equation number 1, x plus y. So what are the two things they want us to find? Types of tickets. Orchestra tickets and balcony tickets. So I'm going to use O for orchestra and B for balcony. So I know we have O plus B equals, now total number sold. 900 were sold. 900. Okay, now we're going to look at money. Okay, total amount of money. So we know orchestra tickets were $3. So we have 3, and be careful here with O. Don't make sure you know it's not 0. So maybe do a little o like that. 3O plus 2B, because balcony tickets were $2. And the total amount of money we earned was $2,300. All right, so now, since we used substitution on the last one, let's use elimination on this one. Okay, so we know with elimination, we need to have opposite variables. So if we look here, we have an O, we have a B, 3O, and 2B. We don't have opposites, so we have to create opposites. If I want to eliminate O, I multiply the top equation by -3, because that's going to give me an opposite. If I want to eliminate B, I multiply the top equation by -2. Let's eliminate B. So we prepare this here, multiply by -2. So now this equation is going to become -2O plus, not plus, so let's write minus, because it's going to be a -2 minus 2B equals -1,800. So I multiplied everything in that equation by -2. Now rewrite this equation right below. So I get 3O plus 2B equals 2,300. Okay, so now when we're ready to have opposites, we write an addition sign right there. That means we're going to add everything straight down. So -2O plus 3O is going to give me just 1O, or just O, right? -2 plus 3 gives me 1. The point of doing elimination, the B's eliminate, and really be careful. My mind's telling me, hey, that's 0, but I know it's an O. So if you wanted to use a different variable for orchestra, so you don't get confused, that'd be a good idea as well. Okay, so now we do -1,800 plus 2,300, and that gives us 500. And we have how many orchestra tickets we had. Okay, so now we can take 500, plug it back in our original equation, so, or one of them, but the top one looks easier. 500 plus B equals 900. We subtract 500 from both sides, and we get B equals 400. Okay, so now we know 500 plus 400, that's 900 tickets. And if we want to check orchestra tickets were $3, so 3 times 500 would be $1,500, and 400 balcony tickets at $2 a pop, so that's going to give us $800. If I take this money, add them together, I get our total cost, which is $2,300. So I know we got it right. All right, last two examples. All right, example 3 says the difference of two numbers is 3. Their sum is 13. Find the numbers. Okay, so we have difference 3, sum 13. Okay, difference means subtract. Sum means add. The two numbers, we don't know what those are. We're going to say those are x and y. Okay, so when we do this, always list x first. Okay, so let's say x, the difference of x and y is 3. So that'd be x minus y equals 3. The sum of two numbers, or the sum of x and y, is 13. So x plus y equals 13. Okay, so now when you choose one of your methods, to me, elimination jumps off the table because my y variables are opposites, negative y, positive y. So I can draw my line under here, big plus sign, I'm ready to add. X plus x gives me 2x. The y's eliminate. 3 plus 13 is 16. Divide both sides by 2, and I get x equals 8. Okay, so now I know x equals 8. I take 8 and I plug it back into either one of my equations. I'll plug it into the second one. So I get 8 plus y equals 13. Subtract 8 from both sides, and we get y equals 5. So we would say the two numbers are 8 and 5. So we can check that. Difference, 8 minus 5, 3. Sum, 8 plus 5, 13, and we're good to go. All right, our last example says, a boat traveled 210 miles downstream and back. The trip downstream took 10 hours. The trip back took 70 hours. What is the speed of the boat in still water? And what is the speed of the current? Okay, so a lot of information here. Let's look at what they're asking us. What is the speed of the boat? What is the speed of the current? Okay, so I'm going to use C for current. I'm going to use B for boat. Okay, so now we have downstream, 210 miles downstream. The trip downstream took 10 hours. Okay, so for downstream, we could figure the average speed there. Okay, so if we went 210 miles in 10 hours, we could say that our miles per hour, we would divide 210 by 10, and we would say we're going 21 miles per hour downstream. Okay, the trip back, or we could say upstream, trip back took 70 hours, and the miles is still the same. We're traveling 210 miles downstream and back, so it took 70 hours. So we know the distance is still 200 miles, but now it takes 70 hours. So we do 210 divided by 70, and we get 3 miles per hour. Okay, so now we know our speeds downstream and upstream. Okay, so now we're going to take the information and find out how much of that is the boat, how much of that is the current. All right, so it says we have, we're trying to find the boat and the current. So if we're going downstream and we were able to go faster, then we could say that the boat and the current are working together. Okay, so in terms of math, working together, we would use addition. Okay, so here we would say the boat plus the current equals 21 miles per hour, or I could have just wrote 21. Okay, so now I have upstream, the boat minus the current equals 3 miles per hour. Okay, so the boat and the current are working together. I'm able to go 21 miles per hour. The boat and the current are working against each other. We're only going 3 miles an hour. So if we see, we have elimination set up. Positive C, negative C. So we can add these. Okay, so B plus B is 2B. The C's cancel. 21 plus 3 gives me 24. Divide both sides by 2, and we get B equals 12. And we know it's miles per hour. Okay, so now we have 12, we can plug that into either one of our original equations. Let's just use let's use the first one. So we have b plus c equals 21. B is 12, so 12 plus c equals 21. We subtract 12 from both sides, and we get c equals 9. Okay, so we know the boat was traveling 12 miles per hour, and the current was traveling 9 miles per hour. And we can add those together. 12 plus 9 gives me 21, and 12 minus 9 gives us 3. So remember, for systems of equations with word problems, we always have to have 2 equations, and we always have to have 2 variables. And our goal is to use one of the methods, graphing, substitution, elimination, to find the value of both variables.